Section 7.3, we're going to look at the effects of outliers on average. And what is an outlier? Well, an outlier is a number in a data set that is significantly different from the other numbers. It is much greater than or less than most of the numbers in a data set. Often you'll know which one is the outlier just on looking at it. Sometimes you have to look a little bit further. But most of the time you can tell which number is the outlier straight off the bat. But sometimes it isn't that easy. So let's look at this first data set that we've got here. 9, 10, 8, 10, 9, 11, 7, 13, 9, and 9. So first things first, as we go, we have to put them into order, least to greatest. So we've got 7, 8, 4 9s, 2 10s, and 11 and 13. First things first, we're going to find the mean, median, and mode with the outlier or outliers in. So if we add 7 plus 8 plus 9 plus 9 plus 9 plus 9 plus 10 plus 10 plus 11 plus 13, add up all the numbers in the data set, we get 95. Well, to find the mean of that, you have to divide by 10. 95 divided by 10 is 9.5. So our mean for this data set would be 9.5. The median, we want to find the middle. Well, considering there's 10 digits, if you split that in half, that would be 5. So 1, 2, 3, 4, 5. Our median is right in the middle between two 9s, so our median is 9. And our mode, the number that you see most often, in this case would be 9 as well. Now what we're going to do is we're going to find what effect that outlier had on our numbers. So looking at the data set, if you see them, 7, 8, 9, 10, and 11 are all within one number of each other. So 8 is bigger than 7 by 1. 9 is bigger than 8 by 1, and so on and so forth, except for when we get to 13. Well, 13 is 2 bigger. So in this case, while 2 doesn't sound like much, it is a bit bigger than the other numbers, so we are going to count that as our outlier. So same thing, we're going to go through and find our mean. This time, if you add everything up, if you add up the 9 numbers that are remaining and divide that by 9, you get 9.1 repeating, rounded up to 9.1. Rounded down to 9.1, pardon me. The median, when we look, if you take a look at the numbers, the median is now for a 9-number data set, so we have to go, in the middle would be 1, 2, 3, 4. The 5th number now is the median, so the median here is 9. And again, mode, the number you see most often, continues to be 9, because there's still 4 9s. We're going to do this again, but we're going to do it with a different data set. This time it's a much bigger data set. This time we're going to deal with 25 numbers. So first things first, as per usual, we're going to put them in order from least to greatest. So we're starting at 0, going all the way up to 9. When you add all those digits together, there are 25 of them. You add up all of them and you get 124. 124 divided by 25 is 4 96/100ths. The median number, well, if there's 25 numbers, we need to go up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then after that is 13. That is our median number, so our median is 5. And the mode, the number you see the most, is 5. Now, in this case, I'm going to look at what the outliers are. And if you look at the span, if you look at the range from 9 to 0, 4, 5, 6, 7, 8, and 9 are all within one number of each other. The 2, the 1, the 2 zeros at the end there's a gap of 2 between the 4 and the 2. So I would say that these last 4 numbers are actually outliers. Now when you're dealing with small numbers like this, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 or 2 points will help you find an outlier. Of course, if you're up in 40s and 50s and 60s or 70s, bigger numbers, 1 or 2 may not be as crucial in that case. But we'll get to that at a different time. Right now, our outliers are 0, 1, and 2, so we're going to remove those. Now that's 4 numbers we're taking out. So now our data set is only 21. If you add up all of those digits together, you get 122. Divide that by 21, and you get 5.76. We look for our median. It's still 5, and our mode is still 5. So in this case of these numbers, on both the first set and the second set, you'll see that The only thing that changed here is the mean. And yes, it only changed 8/10 of a number, but in a data set that goes from 0 to 9, and then a data set that goes from 4 to 9, 0.8 is actually quite a big jump. And up here, you'll see that it went up only 4/10, but again, the data set is only between 7 and 13, and then 7 and 11, so 0.4 is almost a whole half number. Okay? So sometimes an outlier is an important piece of information that should not be ignored. For example, if one student does much better or much worse than the rest of the class on a test or an exam or an assignment, that can still be an outlier, but it is an important piece of information that should not be ignored. We use these outliers because they are actual scores. That is something that somebody actually got. So if somebody scored really well on a test or really poorly on a test, it isn't a number that we need to consider. Sometimes outliers occur as a result of error in measurement or recording. In cases like these, outliers should be ignored. If you find that a number is based on human error or mechanical error or something along those lines, then you want to ignore those. You wouldn't include those in your data set. So, your practice question. This is a record of a group of students' scores on a math test. It contains an outlier or outliers. First thing I want you to do is find the mean, median, and mode and range of the scores with the outliers. Then I want you to find the outliers, identify them, tell me what they are. Then I want you to find the mean, median, mode, and range again of the scores without the outliers. So take the outlier or outliers out and then redo them again. Number 4, what happened to the mean, median, and mode and range when you remove the outlier? You could say something as simple as the mean went up by a certain amount, the median changed or did not change, or the mode did not change. And in this case, for number 5, I want you to tell me, should the outlier or outliers be included, why or why not? Go back and look through the first 2 examples to help you figure out exactly if they should be included or not. Mean, median, mode, and range with the outliers, without the outliers. And then tell me what happened to them.